Good morning, everyone. My name is Carl Fligger, and I'm the NVIDIA Quadro Product Marketing Manager at PNY Technologies. This morning's topic is the recently introduced Quadro RTX, extremely exciting innovations in graphics, particularly in the fields of rendering and artificial intelligence. We're going to give you an overview of the product and the types of solutions we expect it to enable, along with information on availability and some key launch dates. That said, why don't we go ahead and go to the next slide. Jensen Huang, the CEO and co-founder of NVIDIA, announced Quadro RTX at a keynote at SIGGRAPH 2018 in Vancouver. Obviously, you know, NVIDIA had a lot to say about the product, but I like to point people to third parties in addition to what NVIDIA had to say. Someone I've known actually since the mid-90s is John Petty, who's the CEO of an analyst firm, John Petty Research, probably one of the thought leaders in the graphics field. After listening to the keynote, after being briefed on the products, he went so far as to say, this is a significant moment in the history of computer graphics. NVIDIA is delivering real-time ray tracing 5 years before we had thought possible. So this really is a major advance over prior Quadro architecture products. Next slide, please. Computer graphics has been evolving. You know, back when I joined PNY in the early 2000s, we were moving away from something called a fixed function pipeline. A fixed function kind of tells you what it is. It was a GPU that had a graphics processing pipeline, but it wasn't in any sense programmable. It was implemented in hardware, supported OpenGL, older versions of OpenGL, those prior to 3.1. And what the hardware implemented is basically what you got. So you made calls to the OpenGL API. It made, in turn, utilize the hardware. And you got a result. Not a lot of fanciness, not a lot of shading, not a lot of realism in it. The next major advance occurred with the advent of the Quadro FX series. And this brought programmable shaders to Quadro. In computer graphics, basically, a shader is a type of program that was, frankly, originally used for shading, the production of appropriate levels of light, darkness, or color within an image. But now shaders perform a variety of specialized functions in fields across computer graphics to video post-processing, or even functions unrelated to shading at all. Programmable shaders led to a huge array of advances. I've got a snapshot here of a scene out of SolidWorks showing RealView. RealView is the kind of thing that programmable shaders enabled. The next big leap was CUDA. CUDA was an attempt to allow GPUs, which in essence are tremendously powerful math engines, to do more than just graphics. And in this, NVIDIA has been spectacularly successful. Essentially, the CUDA API allows developers to write to CUDA and not have to worry as NVIDIA changes the underlying graphics GPU hardware architecture implementation specifics. It enabled folks to do things ranging from the design of advanced, cell phone antennas, to all kinds of computer-aided design functions such as finite element analysis or computational fluid dynamics or computational electromagnetics, being used very widely in life sciences, physical sciences, and was really the next big thing after programmable shaders. Then with the advent of the Volta architecture, a new type of core was added to NVIDIA's GPUs, something called a tensor core. We'll discuss that in more detail in a moment. But that brought artificial intelligence, particularly the ability to run deep neural networks to the GPU in a very compelling and cost-effective way with dramatic performance advantages over anything that had come before. Next was real-time ray tracing, and this has been, people like to use the term the holy grail. It's something people have been looking at doing for probably the past 20 years. And with Quadro RTX, NVIDIA has finally been able to realize real-time ray tracing. Could we go to the next slide, please? If you look at Turing, there are really 4 essential advances in the Turing architecture relative to Pascal or Volta or any of the GPU implementations that came before it. The first is a new type of core known as RT cores. These are really intended to perform real-time ray tracing. So they're actually dedicated logic in the RTX Quadro GPU that accelerates the computation of how either light or sound travels in 3D environments. There really hasn't been a standard way to measure the performance of this. So Jensen, started talking about gigarays per second, billions of rays that can be traced per second. The highest end Turing cards can hit up to 10 gigarays. The second is the new streaming multiprocessor design, which dramatically improves the performance over Pascal, and it really does allow you to do some rather interesting things like variable rate shading, texture space shading, multi-view rendering, which are very good for dealing with larger models or scenes in particular, and dramatically improve VR experiences. On the AI front, tensor cores first appeared in the Volta architecture products, but they're ubiquitous across Turing. These perform matrix, a fused multiply and addition type of operation that is intrinsic to the implementation of deep neural networks, and can give you up to 500 trillion tensor operations per second. We'll again later show what kind of advances you can see relative to prior generation Quadro or CPUs with this capability. Finally, although I've mentioned it before, CUDA continues to advance. And based on the new Turing streaming multiprocessor architecture, you have up to 16 trillion floating point operations, and in complete parallel with that, up to 16 trillion integer operations per second. This works, of course, with NVIDIA's CUDA 10 and various SDKs like Physics or Flex that NVIDIA provides, which are very important for folks doing simulations or very sophisticated visualization environments or advanced special effects. Could we go to the next slide?
Hi, Carl. I'm going to mute the lines again. Unmute yourself, okay?
Okay, no problem. Okay, I'm back. So if you look at this from kind of the core of the Turing GPU, it's a very large die. It's 754 millimeters square. Has 18.6 billion transistors on it. That's a dramatic leap from Pascal's 11.8 billion transistors on a 471 millimeter die. It's still a little short of the Volta die utilized by products such as the Quadro GV100, but it has a whole bunch of features that take it beyond what Volta is capable of doing. The first is the complete independence of floating point and integer operations. So you can have completely concurrent floating point and integer execution going on in the Turing GPU, which was not available in prior generations. A completely unified L1 cache and the variable rate shading feature.
I checked the tracking. It looks like it'll be here on Tuesday.
The Turing product line, up to 10 gigarays per second are provided. You also have some features that basically make ray tracing more efficient. One is called ray triangle intersection, and this is an algorithm for quickly determining the intersections of rays in a triangle in the geometry to determine whether that ray will ultimately be visible or not. Another is something called BVHs, or bounding volume hierarchies. This is basically a data structure that encompasses all the geometric objects such that nodes can be grouped into sets and enclosed within larger sets, and those can be evaluated again to see which rays will ultimately be visible when the image is ray traced, so that it can basically not waste GPU cycles pursuing ray tracing paths that won't be seen. So these features improve and enable the RT cores to hit that 10 gigarays per second. You also have tensor cores. We'll go into the number based on the products in detail later, but up to 125 teraflops of FP16 are available, 250 TOPS of int8, or up to 500 TOPS of int4. This allows folks in the AI space to choose the accuracy based on what they're trying to achieve. And if you can get by with less accuracy, you can see a significant improvement in Terra operations performance. On the display front, high dynamic range is intrinsic to Turing, as is support for 8K resolution via DisplayPort over a single cable. So unlike prior generation cards such as Pascal, you no longer need two DisplayPort cables to drive an 8K display. It also adds a new connector, Virtual Link, which is intended for next generation VR head-mounted displays, and it replaces if you look at products like the Vive or Rift today, you have multiple cables going into the HMD. Here, a single USB Type-C connector sends the video signals, sends directional audio, sends back and forth bidirectionally information received from the sensors in the HMD to cause the scene to be redrawn based on user motion, things of that nature. Turing also supports NVLink, up to 100 gigabytes per second, and provides GPU to GPU memory access, essentially allowing you to fuse the memory together on multiple high-end Turing cards into a single frame buffer or GPU memory that can be accessed. On the video front, HVAC is implemented in 8K with real-time encoding, and the bit rate's been improved. And obviously, when you improve the bit rate, you end up with higher quality results with fewer compression artifacts. Finally, you have a 6 megabyte level 2 cache and a very high bandwidth interface to that cache. So it really, when you look at all of these features showing up simultaneously, is the greatest single leap forward since the 2006 CUDA GPUs first hit the market. Could we go to the next slide, please? Really, if you look at the products that were announced, the RTX 8000, the RTX 6000, the RTX 5000, they're the fusion of ray tracing, deep learning, and advanced shading. Again, the RT cores accelerate how light, or for that matter, sound behaves in 3D space. It can be up to 25 times faster doing ray tracing functions than Pascal GPUs, can render cinematic quality ray tracing effects at up to 30 times the speed of a multi-CPU-based system using extremely high-end Xeon from Intel or AMD microprocessors. The tensor cores, as I mentioned before, for AI, but from a visual context, particularly in support of ray tracing, they support a technique known as AI denoising, which can dramatically reduce the time between when you initiate ray tracing and have a fully usable image. They can also do some fairly amazing things with resolution scaling, taking a low resolution image and upscaling it without artifacts to much higher resolutions. They're also quite useful for video retiming. Willie, would you mind muting everybody again?
Will do.
Video retiming, here would be a classic example. Perhaps you've got a video that, needs to run in 2 minutes and 30 seconds, but, your team comes back to you and gives you a video that runs in 2 minutes and 38 seconds. Using the tensor cores, you could basically use some fairly advanced AI algorithms to go in and retime the video, process the audio so that the pitch doesn't change, timbre doesn't change, and make it fit that 2 minute and 30-second window. So there are a whole series of implications for tensor cores that go just beyond traditional artificial intelligence and into visual processing. I'm going to circle back and touch on some of those later. Finally, the advanced programmable shading really does, through the techniques I've listed here, variable rate shading, texture space shading, multi-view rendering, decouples the shading rate from pixel density, triangle density, and frame rate. So it really does do some very interesting things to optimize throughput using the new programmable shading model in Turing. Next slide, please. So here's the product lineup. We still have segments of the product line, for example, entry, basic, and mid-range that are Pascal-based. But when you go to the upper range products, in addition to the P5000, which continues in the product line, continues to be available, and is nowhere near to going EOL, you find it's joined by the Quadro RTX 5000. If you look at the high end of the product line, again, we still have the P6000 24GB card, very capable, extremely high performance, but it is being joined by the RTX 6000 with 24GB. Above that, at the ultra high end, we actually have a lot of options. We have the Pascal Architecture GP100, we have the Volta Architecture GV100, and we have the RTX 8000 with 48GB of GDDR6 GPU memory. It's important to note that in the upper range, high-end, ultra-high-end, the prior generation cards will continue to be available for quite a while. And traditionally, our reseller community, our channel community, PNY's partners, have done better when they've had multiple generations of a card in the same classification available. So basically, you have the best of both worlds. You've got RTX, which is absolutely bleeding edge in terms of ray tracing, AI, shading. But folks that maybe need, more of a pure AI play still have the GV100 available. And folks that may have bid in and spec the GP100 and are doing deployments, that card remains available. So traditionally, PNY and our ecosystem of partners has done best when this kind of scenario has been available. Could we go to the next slide, please? So first up, Quadro RTX 8000. The only word I really can use for this card is it's a beast. Those up to 10 gigaраys per second, 10 billion ray tracing operations per second is amazing. 16 teraflops of floating point performance simultaneously with 16 tera integer operations per second is essentially unheard of. The tensor cores provide up to 500 trillion tensor operations per second. 48 gigabytes of GPU memory is simply unprecedented in a graphics card. And in fact, with NVLink, can logically become 96 gigabytes of memory at extremely high bandwidth, 100 gigabytes per second with NVLink. So safe to say that this card is designed for the most demanding visual computing workloads: film, video content creation, automotive, architectural design, or extremely high-end demanding scientific or technical visualization. Next slide, please. Joining the RTX 8000 in the RTX lineup are the RTX 6000 and 5000. These cards will outperform their comparable Pascal counterparts by roughly a factor of 6-fold. The RTX 6000 features 24 gigabytes of GDDR6. The RTX boards, by the way, are the first products coming to market that utilize the next generation GDDR6 memory technology. With NVLink, again, you can scale that to up to 48 gigabytes of GDDR6 memory. Like the RTX 8000, you get up to 10 gigaраys per second, 4,608 CUDA cores, 576 CUDA cores. A step down, the RTX 5000 takes GPU memory to 16 gigabytes, but still uses GDDR6, still supports NVLink, so you can logically fuse the memory to have 32 gigabytes available. Delivers 6 gigaраys per second of performance from 3,072 CUDA cores and takes the tensor core count down to 384. But regardless of which Turing card you choose, you still have full interoperability between the advanced shading, which is rasterization, ray tracing, the compute capabilities, and AI. So you lose nothing from an architectural point of view. You're really choosing frame buffer memory and raw performance. Next slide, please. Now, if we were to look at the RTX 8000 relative to the GV100, there are cases where clearly the RTX 8000 would be a better choice, but there are still instances where the GV100 would be a preferred card. That said, let me point out the situation where the GV100 would still be the best choice for your customers. If your customer requires FP64, double precision floating point computation, The GV100 implements that capability in hardware and provides 7.2 teraflops of FP64 performance. The RTX 8000, in spite of all its tremendous advances, does not support FP64 in hardware. It needs to basically perform that operation in software. So it can deliver half a teraflop of FP64. So if you're doing very advanced CAE, you know, maybe you're in the automotive sector of manufacturing talking to a client and they need to simulate a crash test, they really do need FP64 performance to do that. The GV100 would still be a superior choice. On the other hand, if you're talking to somebody that's more into, you know, media and entertainment, the fact that the RTX 8000 has the RT cores, whereas the GV100 does not. Both products have tensor cores, so you can bring AI to the table to accelerate media and entertainment graphics applications. You actually see the RTX 8000 has a little bit better FP32 compute performance, which ties directly to, you know, graphics, be it OpenGL, DirectX, Vulkan, any of the other graphics APIs. Folks that need to work with very, very large, you know, assemblies, designs, or scenes will find the 48 gigabytes essential. And you don't give up much in terms of peak memory bandwidth. You have NVLink, you have the latest DisplayPort 1.4 plus Virtual Link for HMD for VR. So in a lot of instances, the RTX 8000 will be the best choice, but don't forget that the GV100 is still, in some instances, the card of choice for customers in the CAE space. Could we go to the next slide, please? When will the RTX 8000 be available? We're hoping for January of 2019. That, you know, the official party line is Q1 2019. The MSRP on this card is not cheap, as you can see. It's about $10,000. But let me put that in perspective. One of the demos Jensen did at SIGGRAPH was rendering the Star Wars video of the two stormtroopers running into Captain Phasma in an elevator. In the past, that had to be generated in real time on a $70,000 plus DGX station. It can now be done on a single RTX 8000 for a street price that will be less than $10,000. So tremendous advance in terms of raw price performance. Could we go to the next slide, please? Let's take a look at the RTX 6000 relative to the P6000. And again, we're going from Pascal to Turing. The core count goes up significantly, so I'd expect to see, say, running OpenGL, at least a 30%, if not a little bit better, overall graphics performance. You have the RT cores, which will accelerate the ray tracing. You have the tensor cores, which in addition can further accelerate ray tracing. You have better FP32 performance, which is where my estimate of the OpenGL, or for that matter DirectX or Vulkan performance would come from. Higher bandwidth memory. You have NVLink, and you have DisplayPort 1.4, so you have single cable high dynamic range as well as a virtual link for next generation VR HMDs. I should note that all the RTX cards support the Quadro Sync 2 board, so those of you working in, you know, multi-screen visualization environments, scalable visualization environments where you need hardware synchronization, the same Quadro Sync card you already know and use today works with these cards. The P6000 continues to be available, is a superb board for 4K or 8K video editing, or for doing 360 VR, or for that matter even rendering, although it won't be capable of doing it as quickly as the RTX 6000, which can deliver real-time performance. Next slide, please.
What?
Availability, we're actually going to, in the case of the RTX 6000, this will be the first card to ship. PNY will be working with our partner ecosystem to develop a pre-order program that will be launching in September. We anticipate general availability of the product, in other words, first customer shipment, to take place in November. The MSRP for this card is $6,300. Again, street price will vary somewhat from that. Could we go to the next slide, please? Now let's take a look at the RTX 5000 relative to the P5000. Again, you see an improvement in CUDA core count. I'd anticipate on average 1.2, 1.25 times greater overall graphics performance. The RT cores, of course, will tremendously accelerate ray tracing. You still have the tensor cores for AI operations. Memory size, frame buffer stays the same, but it's a higher bandwidth, 40% faster. You have NVLink, which is a new feature. You also, again, have the DisplayPort 1.4 plus Virtual Link, and again, Quadro Sync 2 is compatible. The 5000, however, the P5000, has been a tremendously popular card, both for PNY as well as you folks. And I would expect the P5000 to continue to do very well, particularly in the high end of the DCC market and for folks doing video editing at either 4K or 8K resolution. Next slide, please.
Yeah, and if I might comment on that, what Carl said, keep in mind for whoever is using the Quadro P5000 in any current project, we will still support it. Keep in mind, PNY will give you 6 months EOL notice before that product goes away, so you can plan to transition your customers to the next SKU. So have the peace of mind that it's still available and your projects that are utilizing this SKU can still be supported.
Yeah, those are all great points, and a major difference between Quadro and the consumer side of the house with GeForce. Estimated Quadro RTX 5000 availability is December. The MSRP will be $2,300. As we get closer to December, don't be surprised if we also implement a pre-order program for this card for customers that are really eager to get a hold of it, but we're not formally announcing a pre-order card yet. Pre-order program, given that availability of this card is still in the December timeframe. Next slide, please. Now, it turns out that RTX is more than just a series of graphics cards because, again, NVIDIA actually employs on their payroll more software engineers than they do hardware engineers. So there's a great deal of software, technology, and optimization and very deep thinking from a computer science point of view that went into NVIDIA RTX technology. The first is an unprecedented degree of interoperability between rasterization, ray tracing, compute, and AI. That is really kind of the foundational layer of the RTX software stack. Above that, you have Turing Ray Tracing acceleration via optics, specifically Optics 5.0 and later, DXR, which is Microsoft's extensions for ray tracing for DirectX 12 and later, emerging graphics APIs such as Vulkan, as well as legacy APIs such as OpenGL. Above that, NVIDIA is doing some things to make ray tracing more predictable and more portable. Some time ago, they developed a material definitions library. This is back in the days of iRay. MDL basically allowed NVIDIA or third parties to define the material parameters of something like china or brushed aluminum, stainless steel, lead glass, and make those physical parameters available to ray tracing in a consistent way, such that if you moved from, say, Chaos Group V-Ray to Redshift, your models would behave properly. You'd still see, results that were consistent. They've now open-sourced MDL. So MDL is now open source, and anyone who wants to add additional materials to the already rather large MDL library can do so. Another technology which they've borrowed, in this case from Pixar, is USD, or Universal Scene Description, which again is a data structure that allows you to include metadata along with the geometry and texture and other information in your scene that makes models more portable from ray tracer to ray tracer. Above that, at the application level, you have APIs, and SDKs to allow the development of applications or plugins. Because if you look at, for example, Adobe Creative Cloud, you can implement things rapidly in plugins and then in a later release worry about integrating it into the core of your applications. Could we go to the next slide, please? So who uses ray tracing? Well, the answer is a lot of folks. Gaming, on the order of 400 games are developed every year where ray tracing is used as a significant component of the content that's ultimately delivered to gamers. In media and entertainment, 500 movies per year and growing rather rapidly. Across product design, which is basically manufacturing, some 12 million designers are now rendering images. In architecture, at least in North America and Canada, we have about 150,000 architects. Those folks actually do on the order of 140,000 projects per year, and they are starting to utilize, in particular, VR as well as ray tracing in lieu of more traditional, balsa wood, cardboard, poster board, let's go build a model approaches. So ray tracing is no longer a niche. It used to be, the domain of Pixar animation studios, Sony animation studios, that is rapidly moving across a variety of other industries, and the uptake number of images is literally in the billions. Next slide, please. The real goal here is to let creative professionals across any discipline bring their visions to life at the speed of light with interactive ray tracing. In AEC, for example, architecture, engineering, and construction, with cards like the RTX 8000 and 48 or potentially even 96 gigabytes of GPU memory, you can now visualize photorealistically with ray tracing cities or urban street scenes down to the smallest detail. Product design, which essentially is manufacturing. You can design with physically based lights and materials in real time. You can go to that Porsche, slightly change the paint, or slightly change the kind of leather used in the dashboard, or change some of the materials used on the air intake, and immediately see the results and make decisions far faster than you could before. In media and entertainment, instead of saving ray tracing for just the most important must-believe segments of VFX, you can now perfect every shot with GPU-accelerated and AI-enhanced rendering, whereas before you had to make hard budgetary trade-offs as to when to use ray tracing versus when to use shortcuts that delivered adequate results, but in some cases didn't deliver complete visual fidelity. Could we go to the next slide, please? As I mentioned, real-time ray tracing has been a long-sought goal, 20 years in the making, for lifelike lighting, reflections, and shadows. It goes beyond the shortcuts and, quite frankly, tricks that have been used to deliver traditional rendering in the past. Truly does replicate the behavior of light and materials in 3D space. It's been used in the past, mainly in the M&E community, to render movies offline. So again, I'll go back to Pixar. They kind of made this happen with the original Toy Story. That was interested. That was rendered on a whole bunch of Spark-based workstations from Sun, running at, I believe, the mighty speed of 100 megahertz. It was simply too demanding to do in real time until the advent of RTX. Could we go to the next slide? Here's an example of the kind of performance improvement you can see using a GPU. And in all candor, I don't yet have really solid numbers on RTX, so I'm actually going back a generation to the GV100, which does have tensor cores, so I can use some AI techniques in conjunction with ray tracing. If I give a CPU 3 seconds to render a scene, and I give a GPU 3 seconds to render the same scene, you see the CPU results on the right. It's very sketchy, only partially filled in, kind of looks like an abstract painting by a pointillist. On the left-hand side, you see the GPU result. It looks essentially ready for prime time. This made a tremendous difference to Blur Studios when they were called upon to do a trailer for Last Call Destiny 2. They were able to basically transition from CPU rendering to GPU rendering, and achieved tremendous increases in speed, the ability to respond to customer requests for changes, and lowered production costs. Could we go to the next slide? Here's an example of where AI denoising can really come to the fore. On the right, you see the scene with AI denoising turned on. On the left, you see the scene with AI denoising turned off. The scene on the right looks very realistic, essentially looks finished. The scene on the left still looks like it probably needs, you know, a few hundred, maybe even a couple thousand iterations before it got to the same point. So AI denoising in conjunction with ray tracing as implemented in RTX can make a huge improvement. So let's go to the next slide. This shows, Willie, do you mind muting us again?
Will do.
Okay, I'm back again. And here, in all candor, I'm going back to Volta GPUs because we're still waiting for the final numbers for the RTX product. But let's set a CPU to a value of 1. And let's then look at a Pascal GP100 running Optics 4.1, which doesn't have the denoising AI optimizations in it, about the 4x the performance of, say, a 4 Xeon system. If I used GV100 with Optics 5, I could see an improvement of about 7-fold. But when I start going multi-GPU, and adding AI to the mix, you see the numbers go up to 54-fold in the case of a GV100 if I turn on AI denoising. And if I had 4 GV100s, which essentially is the same kind of performance you'd get from a DGX station using Tesla V100s, you see an improvement of up to 157x. And when you look at cards like the RTX 8000, it has the capability to deliver that kind of performance from a single graphics card. Next slide, please. Why do you want ray tracing? And for those of you that are in media and entertainment and use ray tracing, forgive me, because we do have a lot of folks in the community that, you know, have used rendering more in a manufacturing context or perhaps AEC and aren't quite as familiar with some of the advantages that ray tracing offers over traditional rendering techniques. So we're going to kind of dissect the two images you see here. On the top is a rendering of a tabletop with some objects on it using shortcuts that were required prior to RTX. On the bottom is the RTX image, which was ray traced on one of the new GPUs. So we're going to go through and pick out some highlights to show the difference between these two images. Could we go to the next slide? Okay, so one shortcut that was used primarily to generate shadows was known as screen-based ambient occlusion-backed lighting. And it does an okay job, but it doesn't do a great job. And if I look at a couple of different areas of the image, starting with the stormtrooper figure, this is again Captain Phasma, so she's chrome-plated. If you look at her right leg, you'll notice there's kind of a large black chunk that just kind of looks like it's missing. If you look at the shadows around the books and the shadow around the rolled up piece of paper, not quite real. They don't have an umbra and penumbra, which you'd get because you have multiple light sources in this scene. And the edge of the room where a couple of walls intersect look a little harsh. Let's go to the next slide. This shows you what that scene would look like in RTX. So look at the Star Wars figurine right leg. The shading is accurate. Look at the pedestal it's sitting on. You can actually see the reflection of the figurine on the shiny base, which before you could not see. If you look at the shadowing by the books and the rolled up paper, you have an umbra and penumbra because you have multiple light sources casting multiple shadows. And the corner of the room itself now has much more realistic lighting, and the rendering of the intersection of the walls isn't as harsh as it was before. So this is an example of how global illumination, which is really at the heart of ray tracing, modeling the behavior of light in a physical 3D space, delivers far superior results to past rendering techniques. Next slide, please. Again, if you go back to the traditional days, you had something called screen-based reflection environment maps. And these were an attempt to represent quickly via approximation to deliver results that the GPU simply couldn't do in real time. The results are good, but there are kind of limits to what this can do and do well. Again, I've highlighted the Star Wars figure, but I've also highlighted its reflection in the mirror. So remember the Star Wars figurine. Remember the reflection of the figurine in the mirror. Remember the reflection of the metallic container that looks like a pencil ball and the Galileo's cradle of stainless steel balls. And let's go to the ray trace slide. Notice the difference between the way the Star Wars figurine appears in the mirror. In the prior scene, which was, shortcutted, basically fake rendered, the entire Star Wars figurine was visible in the mirror, which geometrically was not correct. It would not happen in the real world. Because of ray tracing, only the portions of the Star Wars figurine that would actually appear in the mirror now do so. You see subtle reflections in the balls of the Galileo Galileo cradle, which were not visible before. And if you look at the pencil cup, you see reflections on the side of that, reflecting the color of some other objects that were adjacent to it on the surface of the desk that the traditional approach simply could not generate. Let's go to the next slide, please. So another shortcut was called screen-based refraction depth sorting. And refraction is like passing obliquely through one object and onto another. And this is utilized by screen space reflection depth sorting and ambient occlusion to use a single pass to attempt to compute, as Siri turns on my iPhone, let me turn it off, to compute the reflected portions of an image. It sacrifices accuracy for speed. It provides reasonably good results, and it does it quickly. The problem is it doesn't quite get it right. So I've highlighted the glass. Let's go ahead and go to the next slide, and I'll explain what ray tracing delivers. For one thing, the shortcut completely ignores an effect that happens called caustics. In optics, a caustic or caustic network is an envelope of light rays that are either reflected or refracted by a curved surface or object. And that can cause hot spots in an image. So we've got a glass full of water on the desktop. The glass is circular. It's obviously an object that's going to refract light rays. And so you actually see just to the left of the glass a hot spot on the surface of the desk. That's an example of caustics where light intensity is increasing even though it's inside an overall shadow cast by the glass itself. The shortcut effect simply doesn't take that into account, can't deliver it, can't deliver reality, whereas RTX rendering based on ray tracing can. Let's go ahead and go to the next slide, please. Finally, I'm going to pick on these poor little bears. Traditional rendering uses something called subsurface shading approximation. Creating realistic shadows is extremely compute intensive. So we take shortcuts. We trade performance for accuracy. The tables on the bears on the table are actually gummy bears. They're translucent and they should cast colored shadows. The subsurface shading approximation result treats them, quite frankly, like they were made out of modeling clay or Play-Doh and cast shadows that just look like, normal dark shadows. There's no hint of color to them. Let's go ahead and go to the ray traced version. Next slide, please. Whoops, go back. We skipped over the There we go. So now you can actually tell those are gummy bears, and you see they're translucent. You even see, you know, a little bit of caustics occurring on the gummy bears due to the fact that they're translucent and they do bend light because they're an optically different material than air. And the shadows have elements of the color of the gummy bear itself. So again, these may seem subtle. You may wonder why bother. But if you're in media and entertainment and you're delivering VFX, if you don't do this, you simply won't produce images that are believable to the human eye-brain system. Or for that matter, if you're an architect and you're trying to sell your proposal over a dozen competing firms and you have a client that wants to know exactly what the lobby of their, you know, $100 million project is going to look like at 1:32 in the afternoon on September 9th on a partly cloudy day, the ray tracing will let you figure that out, where the approximation results simply would not deliver believable results. So ray tracing matters, and it matters not just in media and entertainment. It matters across architecture, engineering, and construction. It matters across manufacturing. It can certainly matter across scientific and technical computing as well. Let's go ahead and go to the next slide. So NVIDIA, as they always do, has been working with the industry leaders that have GPU-accelerated rendering software. Chaos Group V-Ray is the market leader. NVIDIA has been working with them for months. They've been working with Redshift as well, Clarice, Final Render, Autodesk's Arnold, and some companies outside of M&E, such as Dassault Systems with SolidWorks Visualize. All of these folks have been briefed on RTX technology, have been working with NVIDIA, and will be bringing products to market shortly that fully integrate RTX technology into their offerings. Next slide, please. The list of folks NVIDIA has been working with is actually much longer than that. So here's a more complete list, sorted alphabetically, not by my prejudice. But the fact of the matter is, you know, key things are here. We've talked about major renderers, but, you know, others, Pixar RenderMan, Octane Render, Adobe with Creative Cloud is on board. Folks like FutureMark, effects houses like Weta Digital, very important, Unity and Unreal game engines that implement RTX so they make it easier for gamers, game developers, or for that matter, the AEC community, which increasingly relies on Unity and Unreal as an engine to show virtual walkthroughs of projects, will find it much easier to integrate RTX technology into their offerings, thanks to the lower-level work that's being done by NVIDIA in conjunction with the vendors you see listed here. Let's go ahead and go to the next slide. So the simple fact of the matter is, and I'm not going to play this video since we've got a limited amount of time, is real-time ray tracing has arrived. If you haven't seen the Star Wars video, remember it originally ran on a DGX station. Now it can run on a single RTX 8000. I encourage you to go to YouTube and play it. Let's go ahead and go to the next slide. So now we're going to shift gears and talk about AI. AI is kind of interesting, and I'd like to quote a Dutch-American computer scientist, Edgar de Dijkstra. The question of whether a computer can think is no more interesting than the question of whether a submarine can swim. Do they think in exactly the same way we do? Of course not. Do they think to the same degree that we currently do? Not yet. But the fact is, they do, after a manner of speaking, think. Let's go ahead and go to the next slide. Intelligence is just not a human trait. It's found in animals across nature. Even invertebrates like the octopus have extremely sophisticated brains and peripheral nervous systems. Octopuses are very intelligent, clever, capable of figuring out how to do things like open sealed jars. One rather mischievous mollusk at the Santa Monica Pier Aquarium didn't like the way it was being treated, so it deliberately interfered with the operation of valves and caused part of the aquarium to flood. So there's a certain amount of awareness of environment, sense of self going on in that situation. If you look at the birds, the corvids in particular, ravens, crows, some other types of birds, African gray parrots, very intelligent. In fact, crows can make tools that are in some ways beyond the capability of primates. Give a crow a piece of wire, it will use it as a spear to try and, nab an insect. If the spear approach doesn't work, it's clever enough to bend the end of it into a hook and try and, pry the insect out that way. Even a chimp can't make that leap forward. So when I hear bird brains, I tend to take it as a compliment these days. The architecture of the avian brain, although rather different than the mammalian brain, is extremely sophisticated. A little closer to human, the cetacea, the whales, porpoises, dolphins, extremely intelligent. Some, like humpbacks, even show the beginnings of culture. Different pods of whales utilize in aggregate the same signals, but they speak them in slightly different dialects. It's an open question as to whether or not humans have been domesticating dogs or dogs have been domesticating us. I know in the case of my rat terrier, Cersei, I'm basically her subordinate biped. The dogs got me very well trained. They're extremely social, gregarious, and actually parse human speech the same way we do between the left and right hemispheres of their brain. Do they understand it to the extent we do? Of course not. But they do get the emotional meaning as well as the semantic meaning. And in fact, my rat terrier has a known vocabulary of about 75 words that my wife and I have to spell or use code to talk around the dog. Our closest relatives, the Hominidae, the primates, Pantroglodytes specifically, highly social primates, have a theory of self, theory of others that they mentally use to interact with their bands, have tool-making capabilities, don't have the ability to produce vocalizations due to difference in their larynx, but exhibit extreme intelligence and problem-solving capabilities. So intelligence just didn't happen in humans, it's happened across nature. Next slide, please. Intelligence in humans, though, is unique because it led to technology, which is kind of ironic because it's technology that led to products like Quadro RTX. So one project that's underway is the Connectome, a complete mapping of the human brain. This is a long-range project that in essence is intended to figure out how every neuron in the human brain communicates with other parts of the human brain and how the various subsystems, such as the thalamocortical brain network, that kind of coordinate overall brain activity, work to give rise to consciousness. Next slide, please. Machines are nowhere near us. We don't need to worry about Terminator. We don't need to worry about Skynet. We're nowhere near having general artificial intelligence. But given a domain, we're seeing some dramatic improvements in machine learning, machine intelligence. If you look at Google, and you tried to give it an IQ test, according to some researchers, its current IQ is 47.28. It's important to note that's nearly an 80% increase over the past 4 years. Baidu, Chinese search company, 32.92, about a 40% improvement over 2014. Microsoft and Bing and Apple, Trail. Since I spent over 20 years at Apple, I'm kind of sorry about that serial result, but that's just the way it is. On aggregate today, from a general purpose point of view, AI is well below an 18-year-old's average score of 97. However, it's come a long way because 2 of the 3 researchers in a prior study back in 2014 found the IQ of Google was only 26. So again, general purpose AI, long way to go, a lot of science, a lot of computer science that still needs to be done, but let's move on to the next slide. So almost every segment of Quadro benefits, and I'm not putting up this slide to dive into deep detail on every one of them. It's just I want you to understand that regardless of what verticals you and your firm sell into, artificial intelligence is going to impact you, from manufacturing to healthcare to science and technical to automotive to AEC to media and entertainment. All of you will benefit from what's going on in AI. Next slide, please. With that in mind, NVIDIA, along with RTX, is introducing NGX, which is AI for visual applications, and it's the integration of NVIDIA AI research into production and workflow tools. This is actually a framework that makes NVIDIA's cutting-edge AI research available in end-user applications through a common API. One feature is called Infill, Intelligent Fill. You see that on the left where I've got a picturesque Italian village on a hillside that's deliberately been defaced. Using an AI sampling algorithm, I can literally go in and restore that image to its original condition. Another one is Super Res. Super Res, maybe I found a 320 by 240, GIF image, and I needed at least a HD image. Using artificial intelligence to go in and sample the image and reconstruct a higher resolution version lets me do unprecedented image scaling, far beyond just bilinear, bicubic interpolation methods, so that I can take a portion of that Lamborghini and zoom in specifically on the taillight and still have it look like real. Another is super slow-mo. Rather than have to go out and have incredibly expensive camera gear using physics for simulation and AI, basically I can render an image that looks as if it were caught by an extreme slow motion camera. These will be available to any application that runs on an RTX GPU. ISVs can add these AI features to their apps without going through all of the developmental expense and training required. And in fact, NVIDIA will continue to improve the performance of these algorithms, and the folks that adopt them will inherit those improvements for free. One company that's going down this path is Adobe Creative Cloud, and they are currently working with NVIDIA to bring this kind of AI through plugins to key Creative Cloud apps. Next slide, please. Another example where AI is going to make a huge difference in M&E is facial animation. Today, this is done through motion capture. You paint a bunch of dots on an actor's face, you point a camera at them, you literally have them act and emote every scene they're required to do. The software turns that into a digital avatar, which later, with a bunch of artistic input, becomes an animated face. Requires artists to spend hundreds of hours. It's very costly, tedious, and very, very difficult to change once it's done. Well, the AI way is rather different. A trained neural network generates a realistic facial animation using only spoken audio input. So I could have my vocal talent talk to a microphone. It would recognize the speech. It would pick up on the emotional context and animate an accurate skeletal muscular representation of the face, dramatically reducing the time it takes for game studios or VFX shops to fully produce an animated face, and giving them in turn the ability to use this technique much more broadly or produce content in multiple languages, whereas before it's typically only done in one or two and everything else is dubbed. The DNN solution, one developed by NVIDIA Research, requires only about 5 minutes of training data and is then able to automatically generate all of the key facial animations. And NVIDIA has been working with a company called Remedy to commercialize this with the same kind of fidelity as existing methods. Next slide, please. Final one we're going to talk about is style transfer. Style transfer is basically taking a video input and making it look as if it were painted by a famous artist. This technique has actually been used in movies in the past. A few years ago, there was a movie called A Scanner Darkly starring Keanu Reeves based on a Philip K. Dick novel. It was shot on film, digitized, and then manually rotoscoped to give it an animated look, a highly stylized animated look. It took 18 months to do. Now, using AI, a GPU can do it in real time. You want it to look like Cezanne, Matisse, Picasso, or you want to go in and design your custom look, you can go ahead and do that, feed the video stream in, have the GPU produce the result in a real-time environment. And this is something we were actually demonstrating at SIGGRAPH, and NVIDIA has shown it as well. So those in the animation space will find some radical changes in how producing stylized animations takes place. Let's go to the next slide. The results speak for themselves. Quadro has won the task 10 years worth of Oscars. With RTX, I think we're highly positioned to probably win the next 10. What I'd like to do is get to a timeline slide, so keep this in mind. We're Oscar winners. We've got Oscar-winning technology. NVIDIA is committed to leading this market. Let's talk a little bit about timelines for the RTX products, and then go ahead and take some Q&A. So again, starting in September, an RTX 6000 pre-order program will be implemented, and we'll start providing the first round of RTX solutions and training materials. We'll continue to deepen and broaden the RTX solutions and training in the October timeframe, followed in November with the first RTX 6000 customer shipments, and at that time we'll be doing a really deep dive and solutions look at RTX 6000. In December, RTX 5000 comes to market, and again, in that time frame, we'll also be doing a much deeper dive into what the RTX 5000 can specifically deliver. Finally, in Q1 2019, the RTX 8000 comes to market, and we'll be doing the same thing. So this is the first of quite a few training sessions, webinars, collateral pieces, web pages. We've got a ton of work to do. We realize that, but our commitment is to deliver you folks the tools you need to make launching these products successful across your respective businesses and customer use case scenarios. That said, final slide, let's go to that. We do have a very strong, very capable sales team in place across the Northeast, Southeast, central part of the U.S., the West, Canada, either French or English speaking, and across the DMR community, and field sales engineers and field application engineers. We also have a general sales inquiry address at gopny@pny.com. We also have a Turing landing page up on the PNY website. So I encourage you to, start pinging your PNY account manager or our FAE manager or FAE as necessary if this presentation has got you to think about possible RTX opportunities and how you can realize them in your business. We certainly want to work with you as quickly as possible. Final slide, please. And
I also want to make, Carl, is for anyone that is working with system builders, or we have system builders attending the webinar, we will make step files available, 2D drawings, thermal information, MTVF data. So if you need that to integrate that into your platform, your chassis, please don't hesitate to contact us. There's many vehicles and ways to get in touch with us, and we're here to help you. You can get in touch with your sales, local regional sales rep, and they can reach us, and our goal is to provide you everything you need to integrate the solution into your environment.
And again, great points. And the only caveat I'd add to that is we're beholden to NVIDIA for some of that information. So specifically things that Willie mentioned, like the STP files, board specification documents, thermals. We're waiting on those from NVIDIA, but as soon as we can get them, we'll certainly be happy to share them with our system integrator WSI community and other assets with our reseller community as a whole. That said, let's go to the Q&A slide, and I don't know if anyone's been submitting questions via the chat function, but if they have, we'll take those, and if there are any questions that come in over the phone, we'll be happy to take those as well.
Yeah, I will mute all the lines now. The other thing I want to make sure to remind you to work with your sales team for specific opportunities. We do offer dev units for these products, which are nicely discounted, so you can use for development and integration. So keep that in mind. And once again, if you have the need for that, get in touch with your sales rep. If you don't know who your sales rep is, get in touch with me or email go@pny.com, and we'll take care of that. And right now, we will mute all the lines so we can start our Q&A.
Okay, so this was deliberately kind of intended as a sampler presentation. We're still waiting on quite a bit of documentation from our partners at NVIDIA so we can develop much more detailed, much more elaborate presentations, but we wanted to make you aware as quickly as possible as to what RTX was about and the potential it unlocks. That said, any questions?
One question is, will this webinar and slide deck will be made available?
Will this webinar be made available? We have recorded the webinar, so it will be available for on-demand. Willie will go ahead and provide the URL for that to the marketing team, and through our various marketing vehicles, we'll go ahead and make that URL available to you.
Any questions?
I saw one question pop up. When will it be available in laptop form factor chips? The honest answer is we simply don't know yet. Obviously, as a new architecture comes to market, it usually shows up in desktop products first, and then at a later point in time shows up in mobile form factors. We don't yet know. We also don't yet know when Turing technology would appear in MXM form factor products. But when we have that information and are authorized by NVIDIA to disclose it, we can certainly make it available to you.
Alvin, who would like to know when he can buy a sampling and testing. Alvin, reach out to us, and once they become available, we'll get in touch with your sales rep, and we'll make that happen.
Yeah, if you were interested in the RTX 6000, it will be sometime in November. Exact date still up in the air, but sometime in November for RTX 6000 class products for developer boards. Any other questions?
If you don't have questions and you think of any other questions or afterwards say, oh, I need this information, please don't hesitate to send us an email, and we will get back to you and assist you.
Yeah, I saw one question flash up briefly about the anticipated double precision, the FP64 performance of the RTX 5000. I would expect it to be 1/32nd of the FP32 performance. So if FP64 is really a key issue, products like the GV100, or for that matter the GP100, may well be a better choice. The RTX products are more optimized for FP32 and AI and the advanced shading. Any direct comparisons of 2080 with these cards? We haven't yet been able to get samples, bring them in, and run exhaustive benchmarks on them. The area where Quadro does dramatically outpace the GeForce cards is in the size of the frame buffer. The GeForce RTX boards top off at a frame buffer of around 11 gigabytes. We go all the way up to 48 gigabytes. NVLink, by the way, is being offered for the first time in GeForce. We do understand there are some differences in Quadro versus GeForce NVLink. We're still waiting on details from NVIDIA on that. So, of course, one of the things we'll do as we have additional information and do the deep dive training is more of an in-depth analysis of Quadro RTX versus GeForce RTX.
Another question is, are there any supplementing items we need to know about?
Sorry, what was that again,
I don't
Willie?
know. It shouldn't have. It could have been something
for
I did earlier.
licensing that will be required?
Are there any software licensing requirements at the present time? Not that we're aware of. Those of you that, actually work with third parties like, say, Chaos or Redshift, I'd refer you back to the ISV in question as to whether or not, once they've implemented RTX technologies, from a hardware as well as a software perspective, there are any differences in licensing. Now, that does bring up an important point, though, regarding the EULA that NVIDIA provides that I can talk about at Quadro relative to GeForce. The GeForce EULA specifically prohibits deployments in what you could consider, mission-critical data center deployment environments. There's no such constraint on the Quadro boards.
One more question, Carlos. What is the expected lifespan of the RTX cards and the Pascal models?
RTX should enjoy at least a 3-year life cycle. The Pascal, I would expect about a year to a year and a half still for the Pascal cards. Again, the P6000, P5000, P4000, none of those cards have entered into our end of life yet, and none of them are going to do so anytime soon. As always, we ramp up a new Quadro architecture while keeping the prior generation architecture around for an extended period, and then after about a year, if not more, slowly taper it off. We've had some products go as long as 4 or even 5 years. One that comes to mind is the K6000 or longer. So it's really customer driven.
The channel partner and you're our partner, so our goal is to provide you support for with your customers. Like Carl said, we still have some cases we're still shipping other cases. And just because the new boards were announced doesn't mean we're going to continue the ones that are work with your sales team. Once again, we will give you 6 months EO notice and plan around your project, and we can have products. So please don't hesitate to contact us, even if you have older boards that you require for our project, and if we can get them for you, we'll work to accomplish that.
Yeah, we can do things like work with you on forecasts, last time buys, so that, the cards are available even beyond the so-called estimated channel availability date on an as-needed basis. Okay, any final questions? Going once, going twice. I think we'll call it a wrap. We thank you very much. Willie, Tanya, and I all thank you for your time. We know it's valuable. We know you're very busy. We appreciate you taking. I see one last question. Could you recap the MSRP again? So I'll do that, and then we'll sign off. The RTX 8000 MSRP in the $10,000 range. The RTX 6000, $6,300. The RTX 5000, $2,300. Street pricing to be determined. We are currently working on, getting PNY pricing in place, and should have that to communicate. That will come to the sales side of the house.
A lot more realistic.
So thank you, one and all. We appreciate your time, your interest, and we look forward to delivering additional RTX information, holding follow-on webinars, and delivering assets and collateral that you can use to help sell, market, and position this incredibly exciting new product architecture and product line. Thank you very much, and have a great day.